Here we have the function z is equal to tan 2x plus 3y. I want you to pause the video and find the partial derivative delta z by delta x and also delta z by delta y. Okay, you finished? Alright, so let's look at it. Delta z by delta x. We want to differentiate this with respect to x. Now, this is a function of a function, alright? You have tan of something, but that something is a function itself, 2x plus 3y. So you're going to use the chain rule. Now you could do it mentally, but suppose we say let u be equal to 2x plus 3y. It means that z is equal to tan u. Now delta z by delta x would be delta z by delta u times delta u by delta x. Alright? And notice the delta u and the delta u is like they cancel, leaving the delta x by delta z by delta x. Now what is delta z by delta u? Well, when you find the tan, the derivative of tan, you get sec squared. So delta z by delta u would be sec squared u. And then what would be the derivative here? Delta u by delta x. Well, delta u by delta x. And well, this part is not partial. So we just use dz by dx instead of delta. Dz by dx. Dz by du. Du by dx. Alright? So it's dz by du times du by dx. Du by dx is what? Well, it is 2. So dz, alright. Oh no. Alright, this thing like this. Let me change it. So dz by dx is equal to, it is dz by du, which is sec squared u, times du by dx, which is 2. So in this case, delta z by delta x is 2 sec squared u. But the thing is, you have to change this u back. You have to get rid of this u because it wasn't there before. Well, I was the one who put it in. What was it again? What was u? Remember what we started out with? There was no u. The only two letters we had were x and y. So we have to finish off with x and y. Get rid of this u. What was u equal to again? Up here, u was 2x plus 3y. So your answer here is delta z by delta x is 2 sec squared 2x plus 3y. Of course, if you wanted to do it mentally, you could say tan of something, differentiate it, you get sec squared of that thing. If you remember your table, you differentiate tan x with respect to x, you get sec squared x. Alright, so you have the sec squared of that thing. Times, you differentiate the inside function with respect to x. So that now is 2. When you differentiate 2x plus 3y with respect to x, you get 2. So you multiply it by 2. So that's what you get, alright? Now, what about delta z by delta y? The partial derivative. Just a reminder, remember, when you differentiate, normally you get this say dz by dy or dy by dx, whatever it is. But this delta is used to show that it is a partial derivative. You have more than one symbols, more than one letters. You take one of them as the variable and all the other letters are constant for the time being. Alright? Later on you do some with respect to something else. Whatever you're doing it with respect to, that is a variable. Just treat all other letters as if they are constants. Alright. Delta z by delta y. Well, we have z is equal to tan of something. When we differentiate tan of something with respect to that something, we get sec square of that something. 2x plus 3y. And now you have the inside function here. Differentiate this with respect to y, you get 3. So what you have here is 3 sec squared 2x plus 3y.